Hey guys, today we're going to talk about inverses from 0 to 2 pi. So just as kind of a reminder for ourselves, we have an expression like an exact value that's set up like this. The sine of 30 degrees is equal to 1/2. So if you remember back in the beginning here, whenever I was trying to undo a sine function or undo any trig function, I did the inverse. And so I did sine to the -1 or arc sine. So if I took the inverse sine of this whole thing, so I did it to this side and to the right side, I would get that 30 degrees is equal to the inverse sine of 1/2. So if you ever see this notation with the inverse sine like this means an angle measure. You are looking for an angle measure. I lost an L in there. An angle measure, whereas for the other one where it was just regular sine of some angle, that's when you were looking for a ratio. So let's talk about how we find inverses. Okay, so I'm going to give you something like this. It says inverse cosine of 1/2. So basically, you're going to ask yourself, what triangle will give me this trig ratio? So what angle measure would make that triangle that would give me this ratio? So the way I always start this is I just draw myself a triangle. So I know that I'm going to have a positive cosine value. And if you remember back in the day, all of a couple of weeks ago, we did this also in state calculus. We know that cosine is going to be an x value, so it should be positive up here in quadrant 1. Okay, so we drew my little right triangle in here, and I know cosine is going to be my adjacent over my hypotenuse. So my adjacent side should be 1, my hypotenuse is 2. If I wanted to finish filling out this triangle, I could do the Pythagorean theorem, or remember that I have a 1, 2, and then this last side should be √3 because it's one of those special right triangles. Okay, so now I think about what reference angle would give me this triangle. Well, opposite my √3 or my middle side should be my middle angle. So this would be my reference angle. So 60 degrees is my reference angle. So if I wanted to write this, I could do 60 degrees. Or if you remember in radians, that's pi/3 radians. But if you remember what I was saying right in the beginning, I know that cosine is positive in quadrant 1, but it's also positive in quadrant 4. So I'd have to repeat this process and figure out what this triangle is down here in quadrant 4. The nice thing about this is it should have the same exact reference angle because I have the same adjacent side, I have the same hypotenuse, so I know that this has got to be √3, therefore this is also a 60-degree reference angle. So it's still going to be a pi/3 angle, okay, but I've got to figure out how I got all the way around. And so down here in quadrant 4, I'm real close to 2 pi, so I always just think about, well, 2 pi is 6 pi/3, so 5 pi/3 is going to be that reference angle. Okay, we're mostly going to keep these in radians. Oops, I totally messed up and couldn't even box my answer. So those are your two answers in between 0 and 2 pi that give you that particular ratio. Okay, so let's look at number 2. So if I look here, this says arc sine. Remember, arc sine is the same thing as saying inverse sine. So sine to the -1 of this. So you might see it arc sine, you might see it inverse sine. So I'm going to go ahead and I'm going to draw my triangle. I'm going to change my pen color. And I remember that sine is going to be negative because I have a negative ratio down here in quadrant 3 and in quadrant 4. So I'm going to start in quadrant 3 when I'm drawing my triangle. Okay, sine is opposite over hypotenuse. So I would have my opposite side is -1. My hypotenuse is √2. Something to remember here is your hypotenuse is always going to be the positive side. So if you have a negative in there, make your opposite or your adjacent negative. Your hypotenuse should be a positive number. Okay, if I did Pythagorean theorem or I recognized that this is going to be a 1, 1 √2 triangle, this would be -1 though, right, because we're going in that direction, and that is a 45-degree reference angle. Okay, so I know that my reference angle should be pi/4, and now I've just got to place it in the correct quadrant. So if I go all the way around, this would be 4 pi/4, so one more pi/4 would get me 5 pi/4. But wait, you said, there's another place on my unit circle or on my coordinate plane where sine is negative. Underneath the x-axis is where sine is going to be negative. So I'm going to have an answer that's in quadrant 3, and I'm going to have an answer that's in quadrant 4. And again, they're going to share the same reference angle. So if I drew this triangle out again and covered up all my nice work, I would know that this side would be root 2, my hypotenuse, -1 would be my opposite, +1, but that doesn't matter here, my sine would still be negative, and I would find that's a 45-degree reference angle. And again, if I'm below the x-axis, I would go ahead and count. This would be 8 pi over 4, so 7 pi over 4 would be my final answer for that. So both of these angles would get me this particular trig ratio. Okay, now what happens when I'm faced with something that looks kind of like this? This is not necessarily a ratio, you know, so I would go ahead and I'd still draw my triangle. So if I'm looking here, cosine is negative. It'll be negative up here in quadrant 2 and in quadrant 3. So I know I'm going to have two answers, one in quadrant 2, one in quadrant 3. I'm going to label my sides. Again, this is adjacent over hypotenuse. So my adjacent side would be negative root 2. Be careful on this one. So I'm going to do the Pythagorean theorem. I would get negative root 2 squared plus whatever this distance is, y squared, I'll just call it y, equals to 2 squared. So if you square square root, the square root goes away. If you square a negative, the negative also goes away. Okay, we still want to keep my hypotenuse positive. So I would get that y squared is equal to 2. So I know that y is equal to the square root of 2. So if I look at this triangle and kind of ignore the negatives and stuff, I know that I have one side that's the same as the other side, so the two legs are equal with that hypotenuse. That makes this triangle a 45, 45, 90 special right triangle because the two legs are equal to each other. Okay, we only deal with reference angles that are 30, 60, 90 or 45, 45, 90, so you have kind of a hint there. It's got to be one of those, 30, 60, or 45. So since my legs are the same, this is a 45-degree angle, which makes my reference angle pi over 4. And to get this over here in quadrant 2, that would be 3 pi over 4. Okay, it's right in front of 4 pi over 4. Remember, I have another answer down here in quadrant 3 with the same reference angle, so it'll still be a pi over 4. 4 pi over 4 would be 1 pi, so I would go one more pi over 4 and get 5 pi over 4. Okay, so that's how we do it for regular ratios. If I'm looking at something like this, though, where I get the inverse cosine of 0. Again, what I'm looking for here is the angle measure. I want to know what angle will give me a cosine of 0. They're not just asking you to find cosine of 0 to tell me on my OIO chart where that is. So if I can't draw a triangle, remember, we always have an alternative. We either want to look for on my coordinates, where if this is cosine, the x-coordinate equals to 0. If it had been sine, we would have been looking for the sine, the y value, or I go ahead and I draw my OIO chart. Okay, so SOA, and this would be 0, pi over 2 or 90, pi or 180, and 3 pi over 2 or 270. So on these, this is a little bit backwards. Remember, we're taking the inverse. So if you're looking for an inverse, you go inside the chart. So I'm looking for this value in my cosine column. So I found one of my values. It's at pi over 2, which makes sense if you think about on your unit circle at 90 degrees, my x value would be 0. I found another 0 down here at 3 pi over 2, which again makes sense. My x value is 0 down there. And again, we're just looking for those values in between 0 and 2 pi, so that's it. Okay, same deal if I'm looking for sine. Again, this is inverse sine of -1. I want to know what angle is going to give me -1 as my y coordinate. Oh, I almost tried to write 0. What's wrong with me? I can see the problem right there. Okay, -1. So again, you can either think about your unit circle and you want to know where y is -1, which would be down here at 3 pi over 2, or you go look in your sine column, go find that -1, and that would be at 3 pi over 2. Now you notice here there's only one answer. That's because there's only one place on your unit circle where the y coordinate can be -1. Okay, so most of the time you'll have two answers, but occasionally you will have only one answer. Okay, now what if I'm given tangent, inverse tangent of 1? If I went to my OIO chart, because I'm like, oh, it's a 1 or a 0, I'm going to go run in there. But I noticed that tangent doesn't have 1 on the chart. This is 0, undefined, 0, undefined. There's no 1s on that last column. So what I'm going to try to do is draw a triangle. Remember, you can always write any number as over 1. So tangent is positive in quadrant 1. Everything's positive in quadrant 1. So I have a triangle that has the opposite as 1, the opposite leg is 1, and the adjacent is 1. If I do my Pythagorean theorem, or I recognize what triangle this is, my hypotenuse would be square root of 2. This is a 45-degree reference angle, which then makes my exact value of my angle pi over 4. So pi over 4, the tangent of pi over 4 gives me 1. Okay, if I'm looking for the other one, because remember, all students take calculus, it's down here in quadrant 3. And again, it's got the same reference angle, so to get all the way over there, I'd have to go past pi, and it would be at 5 pi over 4. So don't let those tangents and tangents trick you. Okay, the tangents and the cotangents do have triangles that you can draw with the ones. You do not have to use your OIO chart if you're looking for the angle that gives you a tangent or a cotangent of 1, it's just a 45. Okay, and that is how you find inverses from 0 to 2 pi.